Good morning, ladies and gentlemen. A little bit of review today. We're going to start off with law of conservation of momentum, this good old thing. And that just says the momentum at the beginning is going to be equal to the momentum at the end.
Yeah.
And so what we have is, we have before an event happens, maybe I throw a bowling ball on a skateboard or I push someone, and then after we have, momentum going on.
Yeah.
But throughout this entire event, throughout this entire process, the momentum is conserved before and after.
Yeah.
Okay. An explosion. The momentum before and after is 0.
0. We had an explosion yesterday, didn't we?
We did. And this, so we have our skateboard here. Get out from there. Okay. And at the very beginning, it was me, skateboard, and the bowling ball. This guy right here.
And now you're free to move on that skateboard.
Yeah,
That's kind of the danger about the whole thing,
Yeah,
isn't
I'm
it?
free to move on here, which makes me a little bit nervous. I'm not gonna get too far away from the wall because I'm not cool like the cool kids who ride skateboards.
Yeah.
But I'm still cool, right? Okay. Don't answer that question. Okay, so I'm free to move this way, and the bowling ball is free to move, right?
Right.
So how come when I throw it this way, when I hurl it that way, how come the bowling ball goes this way and I fast, and I go this way slow?
Yeah. What? You're not pushing on anything, but how come the bowling ball goes that way?
Yeah, I'm not pushing anything. How come it goes this way?
Yeah.
So while I'm exerting a force on it, right, I'm physically throwing it this way, but the bowling ball has mass, so do I, and therefore both the bowling ball and me have inertia, right?
Oh yeah, inertia.
And who has more mass, me or the bowling ball?
You.
I do have more mass than the bowling ball. And so what happens is I'm going to resist the change in motion more than the bowling ball is.
Well,
And-
yeah, you push on the bowling ball. It's a heavy old bowling ball. It says, you can't push me around, sucker.
Yeah, and so it pushes back on me,
That's right.
right? And so when I throw it this way, it pushes back on me, and the bowling ball goes that way at a pretty fast speed, and I go back this way because the inertia of the bowling ball resisting the change is like, no, don't do it, and it
Yeah.
pushes me back a little bit,
Yep.
right?
Equal in magnitude, opposite in direction.
Exactly. And how is that like our rocket here?
We talked about that yesterday.
Right. In fact, I'm actually going to turn it this way. The rocket is just like me on the skateboard, right? And the hot gas that explodes out this way is kind of like a whole bunch of little mini bowling balls.
That's right.
And the bowling balls go this way. The rocket goes this way, but why? Because forces come in pairs. The gas has mass, so does the rocket. And the gas shoots this way, it has inertia, it pushes back in the rocket, pushes this way. So
It's a simple idea.
yeah, and what you see here is Newton's first law, inertia, kind of interacting with Newton's third law.
Yeah.
Forces come in pairs, right? They're all interrelated.
We having a light show here now. You guys, you can't see this, Ms. Moore, but there's something going on with the projector here.
Oh, really?
Look at this.
Oh my goodness, what the heck?
I have
I
no
wonder
idea.
if they're gonna be able to see that.
I'm sure they will.
Fun stuff. Okay. Attention span challenge, as if it wasn't hard to focus with without the light show going on. Okay. So you guys are gonna go to page 210, which I believe we're still in chapter
9, yeah.
Chapter 9, and I'll link that into the canvas for you. Read from explosions, which is gonna be right here. Okay, all the way until 211. Okay, right before explosions in space. You're gonna stop right there.
Although if you read all the way to the bottom of the page, it won't kill you.
No, it's actually kind of helpful.
So pause
so-
the video and do that.
Okay. Have you done it? Go do it. Okay, come back. Okay, so my question for you guys is, why do rocket motors work in space? I think this could be, should we put this in part of the homework, or should we just talk about it?
Well, I think they should write an explanation in their notes. If we were in class, you could write it in a journal. You don't have a journal. You could write it in your notebooks. Can
So-
you write this down?
Yeah, do this in your notebook right now. Why do rocket motors work in space? And we've already talked about how it's like the skateboard, me and the skateboard and the bowling ball.
shh, don't give it away, don't give it away, don't give it away.
We talked about ... Okay. So what I'm gonna do is I'm gonna set you guys loose here. You're gonna go to page 214 and you are going to do numbers 13
14.
and 15. 13, 14, and 15. Page 214, chapter 9.
All right.
Go get them.